Hello dear students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will study the concept of Norton's theorem. It is the theorem or technique used for circuit analysis. Norton's theorem is converse of Thevenin's theorem. According to this theorem, any two-terminal network can be replaced by a single current source of magnitude In, which is called as Norton current, in parallel with a single resistance Rn called as Norton resistance. To understand this, let us consider a complex network. I have considered a complex circuit enclosed in the box with two terminals A and B taken outside, and a resistance RL is connected between these two terminals. This circuit, that is a complex circuit in the box, can be replaced by Thevenin's theorem in Thevenin's circuit. Similarly, this complex circuit can be converted into Norton's equivalent circuit as follows. So let us draw the Norton's equivalent circuit. This is our Norton's equivalent circuit. It consists of a current source In parallel with a resistance Rn. The current In is equal to the current that would flow when terminals A and B are short circuited. That is, In is equal to current flowing through short circuited terminals AB. The resistance Rn is same as that of Thevenin's resistance RTh. That is, Rn is resistance measured with AB load removed. This load is removed and replacing all sources by their internal resistances. Then we'll get Rn. So we have converted the complex circuit into Norton's equivalent circuit with a current source and a resistance in parallel with this source. The stepwise procedure to apply Norton's theorem is: step 1 is we will remove this RL from the circuit. And short circuit AB. So first step is we will remove the RL through which we have to find out current from the circuit. We will mark the terminals of RL as AB and we will put a short circuit across AB. This is our first step. Second step is we will calculate IN, that is Norton's current, passing through the short circuited AB terminals. Then step 3, step 3 will be we will calculate Rn, that is Norton's resistance, as viewed back from terminals A and B. So it will be equivalent resistance across AB similar to RTh in Thevenin's theorem. Next step will be we will draw equivalent circuit of Norton's theorem showing In and Rn, which will be like this. And the last step will be to calculate current IL. The next step or last step will be for calculation of IL. We will reconnect RL in the circuit which we have removed in step 1, and the calculate IL. The formula for IL is equal to IN into RN divided by RN plus RN. By this formula we will get the current required to be calculated from any resistance in the given circuit. Hence, by following these steps we can apply Norton's theorem to any circuit by converting the given circuit into Norton's equivalent circuit and calculate the current flowing through any branch. Thank you for watching this video.